Since the first humans gazed upward in wonder, the night sky has whispered questions we still can't fully answer. We've split atoms, landed on the moon, and now, with the James Webb Space Telescope, we're seeing galaxies as they existed when the universe was just a few 100 million years old. Yet the deeper we look, the stranger the cosmos becomes. We now know our sun is one of trillions of stars. We've confirmed thousands of planets orbiting other suns, some rocky, some with oceans, some in the habitable zone. We've mapped the invisible scaffolding of dark matter and watched the universe itself accelerate apart. And still, enormous gaps remain in our understanding. Where did the galaxies really come from? Is Earth's story of life unique, or has it played out elsewhere, even nearby? What are the invisible forces shaping reality on the largest scales? And are some of the most intriguing clues being hidden in plain sight? Welcome to Pulsar Pioneers. I'm your host, and today we're counting down the top 10 mysteries of outer space. A journey through phenomena that continue to challenge scientists, spark debate, and fire the imagination. These aren't dusty old myths. They're grounded in real telescope data, astronaut testimony, rover discoveries, and theoretical physics. Some have plausible scientific explanations. Others remain wide open. A few sit right at the edge of what we can currently test. We'll explore strange visions hidden in stellar clouds, the puzzling origins of entire galaxies, the hunt for other Earth-like worlds, the mind-bending idea of multiple universes, the invisible matter and energy that dominate the cosmos, intriguing hints from our neighbor Mars, unexplained sightings by highly trained astronauts, theoretical objects that mathematics allows but the universe seems to hide, claims of ancient structures on the moon, and the greatest cosmic puzzle of all, the force accelerating the expansion of everything. Along the way, we'll bring in the latest updates from missions like NASA's Perseverance rover and JWST, separate solid evidence from speculation, and ask the questions that matter. What do these mysteries reveal about the universe and about us? Whether you're a skeptic who demands hard data or someone who loves exploring the unexplained, this countdown will give you plenty to think about the next time you look up at the stars. The universe is vast, ancient, and full of secrets. Let's begin the countdown. Number 10 is coming up next. At number 10, we start with something that looks like it belongs in science fiction, but it's actually a perfect example of how our own brains can create mysteries where none exist. In 1995, the Hubble Space Telescope captured one of the most famous images in astronomy, the pillars of creation inside the Eagle Nebula, also known as Messier 16. These towering columns of gas and dust stretch several light-years tall and sit about 6,500 light-years from Earth. They're active star-forming regions where newborn stars are being born inside dense clouds. When this image was released and shown in the media, including on major news outlets, something unexpected happened. Viewers began calling in and writing letters. Hundreds reported seeing a human face or even a full human-like figure hidden within the glowing gas. Some said adjusting the colors made the shape even clearer, almost like a ghostly simulacrum staring back from space. So what's really going on here? This is a classic case of pareidolia, our brain's natural tendency to find familiar patterns, especially faces, in random or ambiguous shapes. It's the same reason we see animals in clouds or a face on the moon. Evolution wired us to quickly spot faces for survival, so our minds sometimes overinterpret random data. In reality, there is no face, no hidden figure, and no artificial structure in the Eagle Nebula. The pillars are simply interstellar gas and dust being sculpted by intense radiation and stellar winds from nearby young stars. Different color mappings in the image just highlight different temperatures and compositions of the gas, nothing more. Even the powerful James Webb Space Telescope has since photographed the same region in infrared light, revealing hidden stars and detailed structures inside the pillars. Still no faces, just beautiful, chaotic star formation. While this isn't a scientific mystery in the traditional sense, it remains one of the most striking reminders of how we humans interact with images of the cosmos. Sometimes the strangest things we see in space say more about us than about the universe itself. Number 9 is coming up next. At number 9, we tackle one of the biggest questions in cosmology. Where did galaxies come from? We know galaxies aren't scattered randomly across the universe. They gather in groups, clusters, and even larger superclusters, forming a vast cosmic web of filaments and voids. But how did this organized structure emerge from the smooth, hot soup that existed after the Big Bang? For a long time, scientists proposed two main ideas. The first suggested that leftover gas from the Big Bang clumped together under gravity, eventually collapsing into galaxies where stars and planets could later form. The second idea was that stars and smaller systems formed first across the universe, and gravity later pulled them together into the galaxies we see today. Neither explanation fully satisfied everyone, and the truth turned out to be more complex. Today, the leading framework is hierarchical galaxy formation within the lambda CDM model. Tiny density fluctuations in the early universe, tiny ripples we can still see in the cosmic microwave background, grew over time. Dark matter played a crucial role by forming invisible gravitational wells first. Ordinary matter then fell into these wells, cooled, and formed stars and galaxies. Galaxies grew through repeated mergers. Small proto-galaxies collided and combined to build bigger, spiral and elliptical galaxies over billions of years. However, this picture has been seriously challenged in recent years. Since its launch, the James Webb Space Telescope has discovered surprisingly massive and mature galaxies existing when the universe was only 300 to 500 million years old. These little red dots and early giant galaxies appear much sooner and more developed than most models predicted. Some astronomers are now exploring whether galaxy formation happened faster than expected, possibly involving different physical processes in the early cosmos. The large-scale structure we see, clusters, superclusters, and the cosmic web, matches predictions remarkably well on the biggest scales. But the details of how the first galaxies assembled so quickly remain one of the most active areas of research in astronomy right now. Understanding where galaxies came from isn't just about the past. It helps us understand how our own Milky Way formed and what the future of cosmic structure might look like. Number 8 is coming up next. At number 8, we ask one of the most exciting questions in science. Are we alone, or are there other Earths out there? Our Sun is just one ordinary star among trillions in the observable universe. If most stars have planets, and current evidence strongly suggests they do, then the number of planets in the cosmos is staggering. Simple math tells us there could be far more planets than stars. Since the first confirmed exoplanet discoveries in the 1990s, and especially after the Kepler Space Telescope and now TESS, astronomers have confirmed over 5,000 planets orbiting other stars. Many of these are gas giants, but a growing number are rocky, Earth-sized worlds. Some orbit in the habitable zone, the region around their star where liquid water could exist on the surface. One of the most famous systems is TRAPPIST-1, a red dwarf star just 40 light-years away with 7 Earth-sized planets. Several of them sit in the habitable zone and have been studied intensely for signs of atmospheres. The James Webb Space Telescope is now actively examining the atmospheres of these and other rocky exoplanets, searching for molecules like water vapor, carbon dioxide, and even potential biosignatures. While we have many strong candidates for other Earths, we still have no definitive proof of life beyond our planet. Detecting actual life will require much more sensitive observations and, ideally, direct imaging or atmospheric analysis that can reveal chemical imbalances only biology could create. The sheer number of planets, combined with the ingredients for life being common in the universe, makes the existence of extraterrestrial life statistically likely to many scientists. Yet the Great Silence, often called the Fermi Paradox, reminds us that we have not found any clear evidence yet. Whether life is rare or common remains one of the deepest unanswered questions in astronomy. Number 7 is coming up next. At number 7, we enter much more speculative territory. The idea that our universe might not be the only one. The multiverse hypothesis proposes that there could be an enormous number, perhaps an infinite number, of other universes existing alongside our own. Each of these universes could have its own physical laws, constants, and even different dimensions. This idea isn't pure science fiction. It arises naturally from several areas of modern physics. In cosmic inflation theory, the rapid expansion of space after the Big Bang may not have stopped everywhere at once. Some regions could have continued inflating, creating bubble universes that are forever separated from ours. In quantum mechanics, the many worlds interpretation suggests that every quantum event spawns new branches of reality. String theory also predicts a vast landscape of possible universes with different properties. However, there is currently no direct observational evidence for any of these other universes. They lie beyond our cosmic horizon and, by most definitions, can never be reached or directly tested because the universe is expanding. Critics argue that because the multiverse idea is difficult or impossible to falsify, it sits more in the realm of philosophy or metaphysics than hard science. Supporters counter that it emerges naturally from well-tested theories like inflation and quantum mechanics, even if we can't observe the other universes directly. For now, the existence of other universes remains an open and highly debated question. It is one of those rare ideas in physics where the mathematics allows for something extraordinary, but we have no way, at least not yet, to confirm or rule it out. Whether our universe is truly alone or just one of many may be a question humanity never fully answers. Number 6 is coming up next. At number 6, we confront one of the most well-supported yet completely invisible mysteries in the universe: dark matter. When scientists apply our understanding of gravity and the mass of visible matter across the cosmos, something doesn't add up. The galaxies we see are spinning much faster than they should be if only their visible stars, gas, and dust were holding them together. On larger scales, galaxy clusters and the overall structure of the universe also behave as if there is far more mass present than we can detect. Current measurements show that ordinary matter, everything we can see, from stars and planets to gas and dust, makes up only about 5% of the universe's total mass and energy. Roughly 27% appears to be dark matter, an invisible form of matter that does not emit, absorb, or reflect light. We can't see dark matter directly, and it doesn't interact with ordinary matter through electromagnetism. Yet its gravitational effects are clear and consistent. We observe it through galaxy rotation curves, the bending of light around massive objects, the way galaxy clusters collide, and the way the cosmic web formed after the Big Bang. The James Webb Space Telescope has even helped create some of the most detailed maps yet of dark matter's distribution across large regions of the sky, confirming its role as the invisible scaffolding on which galaxies are built. Despite decades of searching with underground detectors, particle accelerators, and telescopes, we still have not directly detected a dark matter particle. We know it must exist because of its gravitational influence, but its exact nature remains unknown. It could be made of weakly interacting massive particles, axions, or something entirely different. Dark matter is one of the strongest examples of how much of the universe is still hidden from us, even though its presence shapes everything we can see. Number 5 is coming up next. At number 5, we look much closer to home, at Mars, and the long-standing question of whether life once existed there. Mars has fascinated people for over a century. Early telescopic observations led to speculation about canals and intelligent civilizations. In more recent decades, conspiracy theories claimed that NASA was hiding evidence of ancient structures, including the famous face on Mars in the Cydonia region and pyramid-like formations. High-resolution images from orbiters have shown that these features are natural geological formations, mesas and hills shaped by wind and erosion. What looked like a face from low resolution disappears in sharper photos. Similar explanations apply to other claimed structures. However, the scientific story of Mars is far more interesting than any conspiracy. We now have overwhelming evidence that Mars was once a much wetter world. Billions of years ago, it had flowing rivers, lakes, and possibly even oceans. NASA's Curiosity and Perseverance rovers have found clear signs of ancient, habitable environments, including organic molecules and chemical energy sources that microbes could have used. In 2025, Perseverance made one of its most intriguing discoveries yet. A rock, nicknamed Cheava Falls, contained unusual leopard spots and chemical signatures that scientists described as potential biosignatures, possible remnants of ancient microbial activity. While this is not proof of past life, it is currently the strongest candidate we have found and will require samples returned to Earth for definitive analysis. Today, Mars is cold and dry on the surface, with harsh radiation. Any life that once existed would have gone extinct or retreated underground long ago. Future missions, including sample return, aim to answer whether life ever took hold on our neighboring planet. The Mars-Earth connection remains one of the most important questions in astrobiology. Did life arise independently on two planets in the same solar system? Number 4 is coming up next. At number 4, we examine claims made by some of the most credible observers possible, NASA astronauts. Astronauts are rigorously trained scientists and pilots. When they report seeing something they cannot explain, it naturally draws attention. One of the most frequently cited cases involves Mercury astronaut Major Gordon Cooper. During his 1963 Mercury Atlas 9 mission, the final solo American orbital flight, Cooper was said to have observed a glowing green object approaching his spacecraft. According to some accounts, the object made a sharp turn and accelerated away rapidly, and radar aboard the capsule also registered it. Upon landing, Cooper was reportedly prevented by NASA officials from discussing the incident publicly. Cooper himself was open about his belief in UFOs throughout his life. He claimed multiple sightings during his military career and later testified before the United Nations in 1978, stating that many pilots had witnessed unexplained craft. However, details of the specific 1963 in-flight sighting have been disputed over the years, and NASA has never officially confirmed an unexplained radar visual contact during that mission. Like many historical UFO reports, it remains anecdotal. In more recent years, NASA has taken the broader topic of unidentified aerial phenomena, UAP, more seriously. In 2023, the agency commissioned an independent study team to examine UAP reports. Their conclusion was that most cases can be explained as balloons, drones, aircraft, or sensor artifacts, but a small number remain unexplained due to limited high-quality data. While astronaut testimony carries significant weight, extraordinary claims still require extraordinary evidence. To date, no astronaut sighting has provided conclusive proof of extraterrestrial technology. These accounts continue to fuel public interest and highlight how even highly trained observers can encounter phenomena that challenge our current understanding. Number 3 is coming up next. At number 3, we explore a theoretical counterpart to one of the most extreme objects in the universe: white holes. Albert Einstein's general relativity not only predicted black holes, regions where gravity is so strong that nothing, not even light, can escape, but also mathematically allows for their opposite, white holes. While a black hole pulls everything in, a white hole would violently expel matter and energy outward. In theory, nothing could ever enter a white hole, but material would constantly stream out from its event horizon. Some physicists once wondered whether white holes could explain the origin of matter in galaxies, or even be connected to black holes through wormholes. However, there are major problems with white holes existing in our universe. The biggest issue is thermodynamics. White holes would require a decrease in entropy, essentially running time backward in a way that violates the second law of thermodynamics. Our universe strongly favors increasing entropy, which is why we observe black holes but have never seen anything resembling a white hole. Despite extensive sky surveys across all wavelengths, no white hole has ever been detected. Some highly speculative recent ideas suggest that very old primordial black holes might eventually behave somewhat like white holes as they evaporate through Hawking radiation, but this remains purely theoretical and unproven. For now, white holes exist only as mathematical solutions on paper. They represent one of those fascinating cases where general relativity permits something dramatic, yet the laws of physics and observations suggest they probably do not occur in reality. Whether white holes are truly impossible or simply extremely rare and hard to detect continues to be discussed in theoretical physics circles. Number 2 is coming up next. At number 2, we examine one of the more persistent conspiracy theories in space exploration, the claim that there are ancient ruins and buildings on the moon that have been hidden from the public. According to this theory, governments, particularly NASA, have been censoring or altering lunar photographs to conceal evidence of past civilizations or artificial structures on the moon. Some individuals have claimed to have worked on photo censorship programs and released what they say are unaltered images showing buildings and ruins. While these claims have circulated for decades, they lack credible supporting evidence. Modern high-resolution imagery from NASA's Lunar Reconnaissance Orbiter and other spacecraft has mapped the moon in extraordinary detail. These images show the Apollo landing sites, astronaut footprints, and equipment, but no artificial ruins or structures. What appear as unusual formations in older, lower-resolution photos are consistently revealed as natural geological features when viewed more clearly. There is, however, one real and exciting discovery related to the moon: water. Multiple missions have confirmed the presence of water ice in permanently shadowed craters near the lunar poles. In addition, molecular water has been detected on sunlit parts of the lunar surface. This water is a vital resource for future exploration and could support long-term human presence on the moon. The discovery of lunar water is scientifically significant, but it does not support claims of ancient civilizations or hidden ruins. Water ice on the moon is a natural result of cometary impacts and other processes over billions of years. As with many conspiracy theories, extraordinary claims require extraordinary evidence, and so far, none has been provided for artificial structures on the moon. Number 1, our final and greatest mystery, is coming up next. At number 1, we reach what many scientists consider the greatest mystery in the universe today: dark energy. In 1998, astronomers studying distant supernovae made a shocking discovery. Instead of the universe's expansion slowing down due to gravity, as everyone expected, it was actually speeding up. Something was pushing galaxies apart faster and faster. This mysterious force was named dark energy. Unlike dark matter, which pulls things together through gravity, dark energy appears to have the opposite effect. It acts like a repulsive force on cosmic scales, driving the accelerated expansion of the universe. Current measurements indicate that dark energy makes up roughly 68% of the total energy content of the universe. That means it dominates over both ordinary matter and dark matter combined. Without it, the universe's expansion would behave very differently. Despite its enormous influence, we still don't know what dark energy actually is. The leading idea is that it could be the energy of empty space itself, often called the cosmological constant. Other theories suggest it might be a dynamic field that changes over time, or even that our understanding of gravity needs revision on the largest scales. What makes dark energy especially puzzling is that it seems to be everywhere, yet it only reveals itself through its effect on the expansion of the universe. We have no way to detect it directly in a laboratory or with current instruments. The discovery of dark energy completely changed our picture of the cosmos. It tells us that the universe's fate is not just about gravity pulling things together, but also about this unknown force pushing everything apart. Whether dark energy will continue accelerating expansion forever, or whether it might change in the future, remains one of the biggest open questions in physics. And with that, we've reached the end of our countdown of the top 10 mysteries of outer space. From faces in nebulae and ancient oceans on Mars, to invisible matter, accelerating expansion, and the possibility of other universes, these mysteries remind us how much we still have left to discover. The universe is far stranger and more wonderful than we once imagined. Thank you for exploring these cosmic questions with me on Pulsar Pioneers. If you enjoyed this journey, hit like, subscribe, and let me know in the comments which mystery fascinated you the most, or which one you think might be solved first. Until next time, keep looking up.